when we go out and take long distance observations, we
Yeah,
can see
that.
we can see orders of magnitude further than you should be able to see on a globe. Okay, so if we go to say a 20-mile lake, for example, okay, there should be 293 foot of curvature over 20 miles. Okay, that's quite a lot. So
Yeah.
we can go to a 20-mile lake and perform different types of observations and laser tests and things like that, right, to try to find that curvature. Right, we're looking for things being hidden by the curvature of the Earth in the distance behind what would be the geometric horizon. Okay, so the horizon should be at a certain distance, and then you should have obstruction of things beyond the horizon due to the curvature of the Earth. When we go out and take these observations, it doesn't match up. Now I have to go in a second, so I can't present much, but I can post a few videos in the side chat that you can have a look at where, you know, people have done the long distance observations. They go over all of the mathematics, all of the details, and everything. So
I don't know. But us just casually going out, and you can't have these types of observations just with the human eye. Also, we're with our height, we're too low to the ground to discover anything.
yeah. So we're using high-powered optics for the observations, exactly. Right? Or we're using high-powered lasers for the laser tests. Okay, and we can calculate how far away the horizon should be. Okay, if you're 6 foot tall, the horizon should be at 3 miles. Okay, so we can go and test for that horizon that would have to be there at 3 miles. Okay, and it's not there consistently or ever.
But where do you get the info from? The S3 mile.
Okay, so these observations are logged, right? High definition videos, PDF files, right? These are logged, right? And anyone can go and reproduce these themselves. I've done a whole series of long distance observations myself, right? Just to clarify it for myself. But I'm gonna post some for you now, and you can watch the videos if you want, right? And come to your own conclusion.
What is the starting point and ending point of flat Earth? Like if it is flat, there should be a starting point and ending point.
Well, we're not claiming
on the land.
Yeah, we're not claiming. We're not. Okay, so you got to remember that flat's not a shape. Okay, we're not claiming to know the shape of the Earth. And what most people do is they try to replace the globe. Okay, they picture the globe model, and then they try to replace the globe with a flat planet. Okay, that's incorrect. Flat earthers are not claiming that the Earth is a flat disc-shaped planet floating around inside the globe Earth version of outer space. It's completely different system, different way of thinking about this system that we live in.
Okay, do you believe in gravity?
How long is this flat bed? Do you know?
Yeah, I don't know the size of the Earth in entirety, right? We're just testing the surface and not finding any curvature consistently. Hold on, you're both asking questions. It's hard to answer both at the same time.
Okay.
And look for this video. Right, so in the side chat, this is a really good video. Okay, Dr. John D. Check it out when you have time. Right, this observation is impossible on a globe.
Hey, I have two questions. First is, do flat earthers believe in gravity, and what about you?
Gravity is something that's required to have a globe. Okay, so you guys need to be able to explain how you can have a globe in the first place. Okay, floating through space, spinning in all of these different directions at the same time at 1.5 plus million miles per hour. You need to be able to explain how you can have oceans sticking to the outside of a spinning ball. You need to be able to explain how you can have gas pressure on a ball, right? On the outside of a ball that's inside a big giant deep space vacuum. Okay, so all of these things, you guys are going to need some kind of explanation for all of these things that seem to defy logic and common sense. So you have gravity to try to explain all of those. We don't need to have such a thing in reality, okay? Because we live on a flat, stationary, enclosed system, okay, where We don't
I
need
haven't followed
gravity in the
direction.
sense that you're thinking of gravity.
Exactly. Then why does stuff fall down rather than any other direction? Like why?
Well,
Why
things,
does it
not
have to?
everything goes down, right? Okay, so we have the air, right? That's what everything's in, the medium of air. Okay, so air is a very light medium. It's not very dense. And most matter, most objects are more dense than the air. Okay, so if you pick up a rock, it's more dense than the surrounding medium of air. So if you let it go, it's going to sink down to the ground. If you have
Why
a
sink
helium,
down?
well, let me get to that. Okay, so if you have a helium balloon, it's going to go upward because it's less dense than the medium. Okay, now why is down down and why is up up? Right? These are like two primary directions that things will go, whether they're more or less dense than the medium. Nobody knows why down is down and why up is up. Nobody. Not from the globe side, right? Not from the flat Earth side. But we can easily test and validate, you know, the why things are going like why something will fall and why something will rise without knowing why down is down and why up is up. Okay, down is down for every single person is the same direction on a flat Earth. Whereas on a globe, down is a different direction for everyone depending on where they're located on the globe, and up is a different direction for everyone depending on where they're located on the globe.
Okay, I have another question. Yeah. Okay, so it's either one of us, like the flat earthers or round earthers, is being gaslit, okay, and scammed, or whatever the word is. Why do you think that? Like, what's the benefit?
Well, I don't think that. For the most part, I think people that genuinely believe the Earth's a globe are not lying. For the most part, right? Like your teachers, your university professors, most scientists, most people that work for the government, even most people that would work for NASA or SpaceX probably genuinely believe that the Earth is a globe. And they're just repeating the information that they were taught, right? And they probably never actually went out and empirically tried to validate that, right? They just, they were just taught that from a young age. They've probably never been presented a solid alternative argument for something else that could be, right? Because they experience the Earth as flat and stationary, but they get told from a young age that, hey, you're just too small. Okay, so you don't see any curvature. You see the Earth as flat, and because you're so small and the Earth's so big, you don't feel it moving. Okay, so everyone experiences a flat, stationary Earth. Most people just believe that they live on a globe because that's what they were taught. Okay, it's a theoretical mathematical model or a concept that most people just blindly believe in, and most people don't really know much about it.
Can you talk about the moon? I don't know how to to come up with the question, but like I feel like the moon should say something. Like, why is it just floating there? You said you don't believe in in a globe, or like space. Like, what is the moon?
I try not to make claims about things that I can't empirically validate, right? Such as things that are too high for me to test, too high for me to validate, or too far away for me to reach. Okay, so when it comes to the sky, right? Everything in the sky moves in a particular cycle, like a big giant clock in the sky. Okay, so we see the sun, the moon, the planet, the stars, right? All taking particular cycles in an east to west direction over our head and resetting back into the same positions for all verifiable history. Okay, the Earth there's no evidence that the Earth is moving, and the celestials are taking a particular motion above our heads. Now, exactly what they are, what medium they're in, what size they are, what distance they are, etc. I don't think anyone can empirically validate that. So it's going to be speculation, and we kind of try to stay out of speculating about things, right? So I don't know, and I apologize. I don't have a counter explanation for every single claim that the globe side makes. I'll stick with what I can empirically validate, like the surface of water not having curvature.
So you're saying, since you can't reach it, you just don't you don't know if it's denser than air or like lighter than air. Thus,
Well, I don't know anything about it, right? I don't know anything about what medium is it in, like what medium is up there. I'm not sure personally. I'm not sure how far away it is. I'm not sure what it's made of. Now, I'm not agreeing with this, but there were actually scientists in the 60s saying that the moon is made out of plasma. I'm not saying that I agree with that, but mainstream scientists were saying that back then. There's different interviews with them talking about that, saying how it's not possible for anyone to ever go and land on the moon because it's plasma. So I'm not sure. People can have different theories about it and different models, right? But what we need is empirical evidence to back up these speculations about the sky.
Alright, who's behind all of this? Like, who's the mastermind to make us all believe that it's rounded?
I have no idea who the mastermind is, right? But it was first proposed, right, by the ancient Greeks, and it was more conceptualized into existence rather than empirically measured or tested. If you look back in history, you need to learn about the way that they viewed the celestials, right, and the way that people observed the sky, and eventually they made a coordinate system out of the way that they viewed the sky, right? The celestial sphere. And they envisioned the heavens as, a big spherical system, okay, where the stars were on the inside of this big giant dome-like sky, right? A way of conceptualizing the way that we view the sky. And later on, they inverted that, right? They said, as above, so below. So the earth must also be like we see the sky, right? So they inverted that spherical celestial sphere model, right? That they envisioned the sky as a concept, right? And they turned that into a terrestrial sphere. Terrestrial meaning the earth. Okay, and that's how the globe came to be. And it's a lot more technical than that, but I don't have time to go over all of the technical details at the moment because I'm just about to head off. But yeah, if you have any more questions.
I have a question.
Mm-hmm.
So, if the land is flat, how can we have so many different time zones when it is morning in America? Why it is or night at any other place? It should be day every time for every country.
Well, if you that's what I was talking about at the start, right? If you try to picture the flat Earth inside the globe model, where you've got a 93 million mile away sun that's really giant, yeah, that wouldn't work. It would always be daytime, right? But that's not what flat earthers are claiming, right? So if you were to speculate that the sun is much smaller, right, than the 93 million mile away globe Earth version of the sun, right? Okay, much smaller sun, much closer sun, taking a particular observational path, right, over the surface of the Earth, it would be lighting up different sections of the Earth at different times. Okay, taking a particular cycle, which would create day and night and seasons. So when you just say it's midday in Australia, right? The sun's going to be directly above you in the sky when you're at, standing in Australia. At the same time, it would be nighttime in Europe. Okay, and then the opposite. Okay, so 12 hours later, it's going to be the opposite of that. Okay, so it's midday in Europe. You're going to see the sun directly above you or close to. right? And you're going to have the opposite in Australia. It's going to be nighttime. So the sun is taking a particular cycle above the surface of the earth, just like we see the sun move across the sky east to west. Okay, we see it rise and set within our field of view due to perspective, right? The way our eyes work. And it moves away from you. And when it's moving away from you, it's taking its light with it. And it's the light from the sun is not able to push through the density of the atmosphere, right? Because a medium like the atmosphere or a medium like the ocean, right? It absorbs light. And then as the light moves away from the source, we also have the inverse square law of light. So the intensity of the light quickly diminishes as it moves away from the source. Okay, so it sort of gets eaten up by the air. Think about this: 200 meters deep into the ocean, it's pitch black. You can't see the sun. You can't see any light from the sun because the sunlight gets absorbed by the medium because water's quite dense. Okay? And the sun can't travel forever through the medium. Now, the air is also a different medium. It's just not as dense as the water. Okay, so it still happens. The same thing happens, but on a larger scale.
So what you're saying is the sun moves further away when it's night and comes closer when it's day. Is that right?
Yeah, the sun's moving over the surface of the earth and lighting up different sections as it travels overhead.
I have a question, okay? Now, based on my observation and probably any other person listening to me, you can see the sun every day directly to your side or like in front of you, where in your the way you said it, you're only supposed to see it above you or like diagonally going further away, but still above you. But I can literally see it in front of me.
Yeah, so as things move away from you in the distance, they're going to appear to converge with the horizon due to the way perspective works, whether it be a cloud or a bird or a streetlight or a plane. Okay, as things move away from you, they're going to look like they go down, 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 and then eventually they're going to converge at the vanishing point, which is going to be at the horizon.
Oh, that has never been the case with clouds and airplanes.
Yeah, it absolutely is the case with clouds. I actually have a really good video to demonstrate that. Okay, so in the video that I'm gonna try to find it in a second.
Bro.
Okay, so we have a guy. Okay, listen, just for a second, just
Yes,
with the
yes.
clouds. Okay, so we want to use the clouds as an example. Okay, so when you see clouds in the distance, they look like they're going down and converging with the horizon. That's just due to perspective, and I have a video that proves that. Okay, so in the video that I'm going to find, we have a pilot in a very small plane, and he's standing on the runway. And when he looks down the runway, we can see the clouds in the sky, and we can see the clouds. They look like they're going down and meeting at the horizon. Now, what you'll notice is that he keeps filming and he goes up into the sky with his plane. When he goes up into the sky, you'll see those same clouds that looked like they were going down completely flatten out into a completely flat deck of clouds, because when he goes up to the height of those clouds, he doesn't have that perspective convergence issue anymore that makes the clouds look like they're going down. Similar to the way when we look down a hallway, it looks like the ceiling of the hallway is going down and the floor is going up, right? And then they meet at a vanishing point, which is a point of convergence. The same thing happens on a larger scale with the clouds. So I'll just try to find a video that shows that exact thing happening. Old Dude just posted a little diagram in the side chat just to give you an idea of what I'm talking about. So you'll see some lines. It's called perspective convergence. It's just the way our eyes work. I'll just try to find this video quickly. Right, so here's just an image, right, while I'm still looking for the video. So this is a hallway, Okay, and it's overlaid over a picture of the ocean. Okay, so you can see that it, you can relate the way that perspective makes you see the hallway, and then apply that to the same way that you see the clouds and the water at the ocean. So yeah, there's a whole bunch of images that basically explain what I was saying in the side chat, right? I'm having trouble finding the video at the moment, but I'll find it shortly. Does that explanation make sense?
Yeah, kinda. It's
Yeah,
still
you just got to learn about
like
perspective.
that.
Like, look at this last image I posted. Okay, so this
If I compare, sorry, if I compare
you go ahead, man.
these two, if I compare the way I see the sun move, okay, and change perspective,
Hmm.
uh, if I compare that to the thing you're trying to explain, it's not the same, and I think that we can see the difference, and I think it's different. It's very different.
Well, it's actually not that different. If you just scroll up a little bit, scroll up to 57 minutes after the hour. Now, obviously, the sun is much, much further away. Okay, and you're seeing glare, and you're seeing you have a lot of atmosphere between you and the sun. Okay, so it's going to behave different than something that's very close to you. Okay, like looking down a hallway, right? You don't have much atmosphere between point A and point B, right? You don't have a light, right? You're not looking at a light like when you're looking at the sun. So yeah, it's not the same thing, but it's the same concept, right? Still perspective. Okay, have a look at this example. I'm just going to put an example in the side chat. Okay, so here's a straight line. Have a look at what I posted. Okay, so it's someone set up a string going horizontally across their kitchen top counter. Okay, and he's got the camera up at the height of the string. Okay, and you can see that the string is straight. Now, what he does is he actually puts the camera down on the ground to represent how we would see something up in the sky based off perspective. And now have a look, right? That straight line that he was pushing that little light across to represent the sun, all of a sudden it looks like it's going downward. Okay, and it looks like that sun's going downward. But it's not, it's just perspective that's making it appear that way. There's a video that shows this entire demonstration with the sun and the countertop, but I'm sure you understand what I'm talking about.
Do you argue that uh, how do you justify the seasons, the summer and winter?
The seasons, like I was explaining before how everything in the sky moves in cycles. Okay, so the sun also moves in particular cycles. Okay, so the sun's going to be taking a particular cycle over different sections of the earth during different times of the year, and that's what's going to be creating seasons, right? So if I'm in Australia and it's summertime, the sun's going to be taking a path where at midday the sun is directly above my head at midday. But during winter, okay, at midday the sun's going to be much lower in the sky because it's taking a path over a different section of the earth relative to where I'm standing in Australia. So at midday in summer, directly above my head. At midday in winter, it's going to be much, much lower in the sky. Now, during winter in Australia, when I see the sun much lower in the sky, in the north, where, say, Europe is, okay, so someone standing in Germany, when it's midday for them, the sun's going to be almost directly above their head at midday. Right? So it's moving in a particular cycle, but when it's winter in Germany, right? They're not going to see that sun directly above their head at midday. It's going to be much lower in the sky because it's taking a slightly different circuit over the surface of the Earth, or a different path, a different apparent path. It might be hard to wrap your head around at first because I don't have a diagram really to show you. But I'll just put, it's like a kind of like a time-lapse photography of the analemma, which kind of explains what I was just talking about.
Then why don't the Antarctica ever get sunlight?
It does. It does. So in the north, sometimes, we have the 24-hour sun in the north, and then sometimes we have the 24-hour sun in the south. But when we have the 24-hour sun in the south, it's 24 hours of darkness in the north, right? Because of the particular circuit, or not circuit's probably not the right word, the particular apparent path of the sun, right? It changes. So let's say we're in the north, right? In, say, Iceland. Okay, so when it's winter in Iceland, when it's summer in Iceland, the sun will be taking a particular path that's very close to the north. Okay, so you're going to be able to actually see the sun in the sky for 24 hours during the day. And then it would be at the same time in the south, it would be dark, right? In the far south, like in Antarctica, it's going to be dark 24 hours a day because the sun doesn't go close enough to that particular area for the light to reach it, right? To light it up.
You were saying,
and now I'm just explaining what everyone observes. I don't know I'm not making a definitive claim about exactly how the entire system of the sky works, right? I'm just kind of explaining what everybody observes and giving you an idea of how it can work over the top of a flat plane. How do we know the plane is flat? Because we go out and we can consistently test the surface of the Earth for curvature, and we can't find any. Right, that's the basis of the argument, is if you have a globe, you have to have curvature. And when we go out and test for curvature, there's zero curvature.
Are you talking about the average, everyday, when you say go out and observe like any person, or like you're talking about scientists or people who do tests with equipment and stuff?
Yeah, people that go out and do tests with equipment. It can be anyone from a scientist to just a general person, right? It's not difficult. Okay, so you just need to find a large body of water. Okay, and if the Earth were a globe, you can calculate how much curvature there should be over that distance of water, and then you can test for it, right? Because if it's a globe, then let's just say we have a 10-mile body of water, a 10-mile lake, or a 10-mile section of the ocean. If the Earth's a globe, there has to be 66 foot of curvature over that 10 miles. Okay, so we can go to a 10-mile lake and try to find that curvature. 66 foot's quite a lot. That's 22 meters of curvature. Okay, so you shouldn't be able to set up a camera on one side of that lake and then zoom in and see the shoreline on the other side of the lake, right? Because it should be hidden behind the curvature of the Earth. But we can do that. Yeah, we can go consistently to this lake and we can zoom in and we can see things that we shouldn't be able to see.
Oh, sorry, you said 66 over how long?
Yeah, 66 feet over 10 miles. But it gets, yeah. You can look that up yourself. You can go on ChatGPT or anything like that. Look, this is what you would do. Go on Google and type in Earth curvature calculator, and there's a huge amount of Earth curvature calculators. So you can put in the height of the observer, put in the distance, and it will tell you how far away the horizon should be and how much should be hidden over that distance. So over 20 miles, right? It gets bigger as you go further. Okay, so 20 miles, say we have a 20-mile lake, there should be 266 feet of curvature over that distance. So if you're standing at a 20-mile lake on one side of the lake, okay, and the Titanic, right? You know the boat, the Titanic that sunk? Okay, just say the Titanic was docked on the other side of the lake, 20 miles away. You shouldn't be able to see it. if the Earth were a globe, right? It would be hidden behind the curvature of the Earth because the Titanic was 175 feet tall. But over 20 miles, there's 266 foot of curvature. Okay, so if you're standing 6 foot tall, you just wouldn't be able to see the Titanic, right? It would be hidden behind the horizon, behind the curvature of the Earth. But when we go to a 20-mile lake, we can zoom in across the lake and we can't see any curvature. We can see flat water all the way across the lake.
Hey, what should I type on Google again?
Earth curvature calculator. I do have to go in a second. I'm sorry. Appreciate the conversation. Come back another time, or maybe I think someone else can pick up the conversation. So yeah, I appreciate chatting with you guys. I'm gonna head off.
All right.
Have a good evening or day wherever you are.
For me,
Appreciate it. Thank you.
You too.
Nice one, DJ. What's up, fellow flat earthers?
Yo, guys, he's a nice guy, okay? But please don't believe him, okay?
Don't believe him.
Go
Believe what?
research.
What shouldn't we believe?
I said, I understand that he's a nice guy, and
Yeah, he's a nice guy.
I see honesty in him. He truly believes the Earth is flat. But
Well, he just said it measures
I
flat.
don't have to believe him.
But he said it measures flat, so if it measures flat, how could I not believe that it's flat?
Do your research.
Yeah, that's what I'm saying. He says it measures flat.
Okay.
So if it measures flat,
All right.
how could it not be flat?
If it measures flat, then it's flat.
Yeah.
But he says it measures flat.
Yeah. Well, it does measure flat.
It's not facts. Doesn't have to be facts.
No, it's not just what he says, though. It's how the Earth is measured when anyone tries to measure it.
Okay, guys. Psyclone is also seems like a nice, honest guy, but guys, don't believe these flat earthers.
I agree. Don't believe me. Don't believe me. Believe the Earth. Go and check with the Earth.
Listen, if it's not meant to look like a rounded, sphere.
Oh, so you believe the government?
Like it.
You believe the government, right?
Not necessarily.
That's who you're believing. You're believing NASA, but not nice old DJ there.
It's not only NASA, bro.
Yeah, it is NASA. They're the one telling you it's a globe. The U.S. military. So that's who you're believing. Not harmless old, polite, honest DJ. The U.S. military. Famous invaders of poor people. Blower-uppers of children. That's who you're believing. I bet DJ's never drone striked a child.
If they say the sky is blue, you're not going to believe them, right?
Well, if I observe the sky to be blue, I don't have to believe it. I can just observe it, right? Does that make sense?
Yeah, makes sense.
But then if they tell you, actually, we're the US military and we're telling you, although it looks blue, the sky is actually green, you would believe that, right?
No.
Yes, you would, because they've told you the Earth looks flat, but it's actually a big ball, and you believe that.
No.
And you've never seen the Earth looking like a big ball. You've just seen it looking flat. But you believe them.
Okay, they probably sometime in their lifetime said that the sky is blue, and you still believe them.
No, it's not a question of belief. I just explained it to you. You observe it. But they've told you that what you observe isn't true and that you should believe their story instead. And that's what you're doing. You're believing a story over your own God-given senses. Why are you doing that?
It just makes sense. It just makes
No, it doesn't make
more
sense because your senses don't detect it. It's nonsense. It's not
It's just
sensed.
logical, bro. It's just more logical.
It's not logical though. It doesn't conform with even your base senses, so it can't be
Okay,
logical.
but then I bet flat earthers think it's flat because when something
Because it's
falls flat, it
observed,
goes down.
measured. No, because it's observed and measured flat. Like, why would you believe you are 5'9" or whatever you are? Because you're measured to be so. That's it.
But the Earth is not measured flat.
Oh, okay. Is it not? What about a lake? What's a lake? Is that not flat?
It's supposed to be.
Okay, so the lake's flat.
It's flat. It doesn't.
Yeah, so the water is flat. So the majority of the Earth is covered in water. So the majority of the Earth must be flat.
No, it doesn't have to.
Well, if the water's flat, it does.
Bro, do you comprehend how big the Earth is?
How big do you think it is?
I mean, it's big. It's big.
Well, I agree with that, but I mean, that doesn't really mean anything. What does that mean? Earth is big, okay. Big and flat.
Oh,
You think saying it's big means it's a ball? Come on, dude.
bro, you think if the floor in your house is flat, the Earth is flat?
No, I think if the floor in my house is flat, then the floor in my house is flat. Whereas I guess you think it could actually be curved, even though it just looks flat and measures flat and is used flat. It's actually curved. That's your logic. Come on, dude. Because the US military told you so.
Listen, the floor in my house looks flat. Sometimes.
Are you like under your bed sheets right now or something, dude? With a little flashlight.
Hey, listen. When you take a closer look, sometimes you find curvatures, even though you.
Nah, no one finds curvatures. The Earth has no curvature. That's why we're here.
As we're here.
That's why we're here, because there's no curve. If the curve was here, we would not be here. But the curve is not here, so we are here. Understand?
Okay, what if there was curve and gravity?
Well, if we imagine the fairy tale globe story is true, then what? Then it's true. No. I mean, you can imagine the globe is true, but when you actually go out and measure it, you'll find it's not true. So
Okay,
you can keep believing it, but why would you?
Okay, that's the same thing with you. Like, why are we here? If the floor, if the Earth is flat, like we could just fall sideways or
What?
upwards.
Fall sideways from upwards. What does that even mean?
I said or upwards. Like
We could, if the ground that you're on is flat, you could fall sideways or upwards. Is that what you just said?
Yes.
That makes no sense at all, dude. So if you stand on a table that's flat, you could fall sideways or upwards because it's flat. Think about it. What are you talking about?
Bro.
You're just saying shit.
You can only fall down because the gravity is under you.
You don't have down on a ball. You don't believe in down. You believe in inwards and outwards.
No, it's the central point of the Earth.
No, which way is down? Which way is down?
There is no down, yeah.
There you go. So why are you saying down if you don't believe in down? See how the globe fucks you up? You can't even say down anymore. You can't even operate in reality and say up and down. That's how messed up the globe is.
Common sense and not scientific.
Yeah, your common sense tells you that the Earth is flat and motionless. Have you never heard them say it's too big to see the curve? And you can't feel the Earth spinning or moving? So yeah, your senses tell you it's flat and motionless. Then the
So-
government tells you it's a big spinning ball.
Okay. So, when you're in a train, right? It's
Oh,
going
here we go.
200 miles per hour, and you have a glass of water. Why doesn't it just spill? Everyone goes.
Because it's in a container.
No, even if it's open.
How does that water stay in its container?
Because it's getting it. I don't know, but
Because it's contained, isn't it? Water needs to be contained. The surface will be level.
Like,
Yeah. Think about that in reality.
why doesn't everyone just fall
Why doesn't everyone just
back,
fall? What, just fall into the ground?
back when not fall backwards when the train is going forward 100 miles per hour?
Because you're in a container. You're in a train. Try sitting on the roof of the train.
No, actually, that's the same thing.
No, it wouldn't be the same thing. This is why they don't let you sit on the roof of the train unless you're in India or something.
But what about like roofless cars?
Yeah, same thing. You're in a container. You're shielded from the outside air that you're traveling through. But on the globe, you're supposed to be not in a container, are you? You're on the outside of the object that's moving.
Okay, so you would have to see the container in order to know you're in a container. What if the container was built out of stuff that are not like seen, like not solid, like air or whatever it is? Like, I'm not too advanced with these stuff.
I don't know, dude. I think you're trying too hard for the globe. You should just be looking for some evidence for it. I mean, I get it. You believe in the globe, but it doesn't sound like you've actually got any evidence for it. And that's what you'd need. Because we're not just here to believe shit. We want some evidence.
So I have one last question before I go to bed.
A bedtime question? Okay.
Yeah, before I go to bed, I got one last question and I'll go out. So why does the sun set completely below the horizon instead of just getting smaller and fading away?
Well, it depends, because sometimes you can see the sun appearing to get smaller and fading away. It depends where you are and what the conditions are of the air that day. But yeah, you can observe the sun appearing to sink into the horizon. This is an optical effect. Things will decrease in apparent altitude as they get further away from you. Like if you're on a long street and you see the street lights, over a distance, it'll look like the ones further away are lower down, closer to the ground. They're actually the same height, but because of the way your vision works and perspective works, everything moves towards the horizon, the vanishing line. And eventually, that light won't be able to reach you. The combination of your perspective and attenuation of light in air means that the light can't travel forever through the air. It eventually blocks it out. It's a combination of things which can result in what looks like the sun sinking down beneath the horizon. But that doesn't tell us the Earth's a ball.
So you are telling me...
I don't think he understood. Because...
So you are telling me...
Because Psyclone, you're...
Hey, dude, raspy dude who's hiding under the bed covers. That guy was asking his question. Let him finish.
No, bro. You're explaining a different thing because he's saying...
No, dude, we're gonna let this guy... This guy needs to go to bed. He's very tired. Let him ask his question and go to bed. Then you can continue to whatever you're doing.
Yeah, go on now.
Okay, so you're telling me that that I'm seeing an illusion, like it's an illusion that the sun...
Well, it's a function of perspective. Like when you see things in the distance getting smaller as they go away from you, you could call that an illusion because they're not really getting smaller, but you just know that's a function of perspective, right?
But the sun is like...
If you see a plane flying away from you...
It's like... Yeah, but I can see it go down, right? So...
Yeah,
You
yeah,
can see it like
because things over a distance appear to compress towards the vanishing
If-
line, which is the
Yeah, but-
horizon.
because so you believe there's a horizon, right? There's
I
a
don't.
point where.
It's not a belief; it's a phenomenon that's observed.
So okay, so if there's a horizon, and after
Yeah.
after that point, things start going down. So where?
No, no, no.
where
The
is it
horizon
going
isn't
down?
the curve of a ball where the ground is going down. It's an optical limit. It's the limit of your optic. It's not a. It's not a curve. It's not a curve of the ground.
I can still use optical instruments and still see the same thing, right? So
You can see the horizon. Yeah, yeah. Because
so
every optic
whether it is
has a limit.
using my eye or using a telescope.
Yes,
It's the
yes.
same
It's an
thing.
optical phenomenon that's apparent through any optic, right? But it's not curvature. It's optical. You understand?
Yeah,
An
but
optical limit,
why
not a
can
physical
we
one.
go in one direction and then end up in the same place?
Is this another guy now? Who's talking? You guys need to keep it straight. I need to know if I'm talking to one person or two or three.
It's found, but found. Please, before we jump into the next subject, like change the question. Let me just repeat Mahom's question. Mahom, did you forget your question or what? You said that it sinks. It doesn't go away, like go far away. That it meets with the horizon. It actually sinks. You can see half of it, and then you see
Yeah,
quarter, and then like it literally sinks. So based on our observation, there is some curvature around roundedness.
So why are you saying the sun sets?
Why do
So
you
if-
call that an illusion when you call like seeing the Earth as flat as
Well, what's your explanation? Why is the sun setting?
because
the only
it's not-
explanation is because of a curved Earth.
What does that
Because
look
of
like? So the sun
Only
is
there's
moving downwards. The sun is moving downwards beneath the curvature. Is that what you're saying?
Yeah.
So that's not what they're saying, though.
I mean, the Earth is spinning, so it's the same thing.
Oh, so when you're seeing the sun going down, what are you actually saying is happening?
So yeah, when I'm saying it seems like the Earth is the sun is going down, but it's actually the Earth spinning.
So you're spinning backwards, you think?
Exactly.
Okay, do you have any evidence for that?
Hey, you don't have to be spinning backwards. Maybe the sun is
Yeah.
just.
Well, you do. For the sun to go down, you would need to be tilting backwards.
Like the sun just could be behind
Exactly.
you or to your.
So have you got any evidence that you're actually spinning backwards?
Yes.
I don't have an evidence, but
Obviously,
I mean,
you can observe the sun.
Well, you can observe the sun appearing to move downwards, but now you're saying it's not the sun moving downwards, it's you spinning backwards.
Now,
So have you got any evidence for that?
if you watch both sunset and sunrise and sunset, you can see that it's spinning.
You see the sun moving. You're saying you're spinning backwards. So you got any evidence for that?
You can feel it, like when you can feel
You can
it
feel.
moving
What do you
backwards.
feel? What do you feel?
Like I feel gravity pulling me back.
You feel gravity pulling you back. What does that feel like?
okay,
I'm just
so
joking, man.
I
yeah,
feel
so-
the earth move
so-
under my feet.
Okay, so far you've got a claim that
So-
you're spinning backwards, but no evidence for it.
yeah, we have no evidence, but for a flat Earth to be
Well, I'll just dismiss that then.
correct, then the sun has to get smaller and smaller and fade away.
Well, arguably
That's
we
not the
do
case.
have some videos. I'm sure
That's not
folk
the
can post them
case.
in the chat.
I've
That
always,
the sun does
I mean-
decrease in angular size.
I mean, I like seeing the sun fade. So I see it always like setting down and not fading away.
Yeah, but what if that's just because
our
where you
question
live, the conditions make that the case? But if you were somewhere else, you would see something different.
Like where? Something different where?
Like, in some places, depending on the atmo conditions, the air conditions, you can see the sun appearing to get smaller as it moves away.
So, I'm not aware of those instances.
Well, if you look in the side chat, I'm sure people can post some GIFs or videos for you. But needless to say, you're not seeing the sun going down because you're on a big spinning ball and you're falling backwards. That's not happening.
Right. Sorry. They have been. We have been. People have been posting stuff.
Yeah, so there you go. Look in the side chat. Just because you haven't seen something doesn't necessarily mean it never occurs.
Bro, I've been to like 3 countries.
I only
and I
believe what I
have never
see.
seen
So
that phenomenon.
yeah.
Yeah, so 3 out of what? How many countries? 200 countries? That's not very many, dude.
How many locations? Like I've been to Europe, Africa, and Asia.
Okay. So
I'm in the equator, so
now listen, it's in the chat. Folk have posted it in the chat. Just go and have a look.
Hey Demon, the lady in the back already told you to shut up and go to sleep, so why don't you do that?
I hit a nerve with a flat earther or what?
You're about to get slapped by someone in the back, so we don't want that to happen to you. So just mute up, and go to sleep, because
Actually, I
everybody's
think it
trying
was
to
the
sleep
other
there.
guy who
I'm
was going to
not
go to
sleepy.
sleep.
I'm not sleepy though.
Don't get emotional, kid.
It was the other guy who was going to go to sleep. The guy who's hiding under his bed covers. He's in for the long haul. He's got his
He's
flashlight.
hiding
There's no
there
one fighting under my
because
bed
there's
covers.
people
What are you talking
sleeping.
Oh,
about?
not you, the other guy who's like, okay,
Oh,
I can't have people hear me,
oh.
but I'm arguing
Okay.
with the flat earthers at night.
What's up?
Bro, I got flat earthers mad, bro.
He's
You
getting
see?
Yo,
flat.
what's up, twin?
He's gonna get flat smacked by
Wait a
the
minute.
lady.
I remember you from somewhere.
They're just going to hit him with a
Hmm.
slipper.
With the
Yo.
flat flip flop.
Holy shit. Didn't you build that children's hospital all by your bare hands, dude? That was crazy.
Yeah, bro, that's me, bro. You remember me, bro?
Yeah,
No,
oh my
we don't
god, bro.
remember you.
Thank you.
No,
You're such
no,
a
we
hero,
don't.
bro. Thank you.
Yo, bro.
You saved my brother's
Me
sister's
just the moment
brother's
you say,
nephew,
man.
bro.
Bro, you're so welcome, man. Like,
All
I do
right.
this, like,
Have a
you know, I
have
just
a
want to help
family
people,
reunion
so...
somewhere else, guys.
Yeah, go to a
Sorry.
different NBC, ladies.
No, thank you. Here with the flat earthers.
So these guys think they're spinning.
Yo, please,
These guys
please,
think
please,
when they
please,
see a
please.
sunset that they're spinning backwards at 1,000 miles an hour. Has anyone got any evidence for that?
Please, guys, man. Please, bro, I have a conversation with a fan, yeah? You can't disturb us, you know? So please, for 1 moment.
Yeah, put yourself on mute, dude.
Do you want an autograph, man?
So have you guys given up on the globe already? Is that a concession? Sounds like it. What's the best globe proof? Let's hear it.
Alright. I'm back, guys. You miss me.
All right, what's your best globe proof?
Huh?
What's your best globe proof?
Globe proof?
Mm-hmm.
I don't know.
Oh, so why'd you believe it?
So.
But you believe you live on a big spinning ball?
I mean, yeah, kinda.
Why, if you don't have any evidence?
Well, low-key, all the other planets are balls, so...
How'd you know that?
Because NASA said so.
Oh, so the U.S. government told you so. So it must be true. Because they don't lie, do they?
Well, I mean, I wouldn't know. I'm not from the U.S.
So you wouldn't know. So the U.S. government must be telling the truth because you don't know.
I don't know, probably.
Probably. That sounds like a smart way to base your entire worldview on.
I don't know, bro. I've never been to space.
Yeah, so why would you believe their fairy tale Hollywood stories about it?
Because, like, I don't know.
Because you're lazy.
Is
You
NASA
don't
run
think.
by the government? I thought it was a private organization.
No, come on, dude. It's the U.S. It's part of the U.S.
I'm not from
military,
the
basically.
US. What do you expect?
You don't have to be from the U.S. to understand that NASA is a government organization.
I'm not from the US.
But like, why
so-
would they lie to us about that?
Yeah, why would the government lie, guys? The government doesn't lie.
Why? Like, all the governments say that.
Governments don't lie, do they, guys?
No, they don't lie. I don't think they lie, man.
Has been
Yeah, governments
proved
can't lie.
all the way
That's
since
like a
like
useless topic to lie
ancient
about.
times, though. With like,
Yeah,
In fact,
control. Why
governments
would
have
they want
never
to?
lied.
What? Yeah, why would the government want
I
to
wouldn't know. I
control
wouldn't
your
lie back
entire
then.
worldview and belief system? Why would they want to do that? It doesn't make sense.
Why do you believe the Earth is flat?
It's not a belief. I experience it every day. Go outside.
Nah, man. But
I am
like,
outside. Well,
Okay,
not
you'll
right now,
notice.
but I
You'll
do go
notice.
outside.
You'll notice that the ground isn't spinning at 1,000 miles an hour. Then.
Yeah, no shit. We're spinning with it.
Oh, are we? So it is spinning at 1,000 miles an hour.
Yeah, that's low-key how physics work.
Okay, so how do you know you're spinning at 1,000 miles an hour?
I don't know. Science says so.
Science said so. Is science a person? Who's that? Mr.
I
Science.
don't know. Scientists.
You talking about Bill Nye?
You just saw a cartoon on TV
Yeah,
and
Bill
believed
Nye
it.
said so. He's the GOAT. He knows everything.
I don't know is a good answer.
Yeah, Bill Nye
said
also
so. I
thinks.
believe everything what Bill Nye says.
Well, Bill Nye also says that men can get pregnant. So.
No, he
Good luck with
doesn't. No,
Yeah, he
no,
does.
I wouldn't watch Bill Nye, so I wouldn't know anything
Okay,
about
okay.
that.
So it's fair to say that you've got no idea what the Earth is. You just believe it's a ball because you were told so.
I mean, yeah, I wouldn't know because I've never been to space. But like,
Well, maybe you should use your brain and think about it.
nah,
But
man.
you
I'm
can
thinking
see
that
the
it's a ball.
curvature when you're on a plane, bro.
Yo,
Like,
everyone.
why?
So now that you've
That's-
realized that you think it's a ball, maybe you should try and find some evidence for that.
I don't want to. Playing Battlefield is low-key fun. More
Okay,
fun than this.
put yourself on mute then.
No, thank you.
Nah,
Stay
man.
lazy
Bro.
brained.
Bro, Erson, I have
No,
a
thank you.
question.
Playing
No,
Silent Hill F is
bro.
That's
better.
okay. Well, we
than
can do
doing
it.
research.
We can do it for you.
Imagine doing research in the Big 25.
So,
Yeah.
Boo.
See,
Boo.
you revel in your own
Boo.
ignorance. Of course, you're a globe believer. A perfect demonstration. Doesn't know anything about the globe. Just believes it. Doesn't even want to
what's the
challenge
radius?
it. Doesn't even want to
What's the
investigate
radius?
it.
Psyclone.
I don't know. They taught us that in school, but I don't remember it.
Yeah, you've forgotten all the fairy tales that you're supposed to believe, but you still believe them.
I mean, yeah, Bill Nye said so. It's like
Yeah, the
science.
TV, government
stuff.
and TV said so.
You know,
So it must be true.
like Jesse Pinkman said, you know, yeah, Mr. White, yes, science.
Yeah, you're watching too much TV. That's why you're lost in
No.
reality. Yeah, that's why you don't understand
TV. I watch
reality,
it on my PC.
because you're
I
stuck
don't
on
watch TV.
TV. Yeah, you're a
I don't
TV
watch
watcher.
TV. I don't watch
Yeah, your
TV.
head
I
is a
watch it on my
TV.
PC on Netflix.
Oh,
My
whoa,
PC is not a-
okay. Must
My
be
PC
very
is not a
different
TV,
then.
but it's okay.
That's a highly intellectual difference.
television program.
I'm low-key smarter than you anyway.
You're a TV guy.
that's true, man. That's true. He's smarter than
Yeah.
Yeah, because
me
he
ask you something
blindly
then.
believes
What's 2 plus
government
1?
cartoons
What's 2 plus
and
1?
fairy tales.
Nah,
That's so
man.
smart.
What's 2
It's
plus
so
1?
smart. Why would the
I have a
government
fact.
lie? That's so smart.
Now, I have a fact, guys. Why the Earth is round, you know? So, if the Earth was flat, why is
That's your wrong start. You're starting wrong.
No, man. Why
You're starting
is
wrong.
Bro, let him speak, bro.
one side of the Earth night and the other side day? You know what I mean? It doesn't make
Okay,
sense.
prepare yourself. Prepare yourself. This is radical. The sun moves. Whoa. You notice that?
I have a question for the Psyclone. Can I ask my question?
Is it about why the sun moves?
No, it's something else.
Have you guys, let me ask first, have you guys noticed that the sun moves?
I got you. I mean,
Sun move.
no, in my opinion, the Earth moves and the
Yeah.
sun, it still moves,
But when you
like,
go
not
outside,
around the Earth.
you see the sun moving, right?
No, but
Well,
the Earth is moving. He's
that's just
right.
the Earth
The Earth
moving.
is moving. Yeah, it's true. Yeah, it's true.
No, you're only observing the sun moving though.
Okay, so can I ask my question now?
Well, once we get to the bottom of this, because
No,
you
please,
guys are
please.
saying you
Just really
see
quickly. I'll
the
let
Earth
you
moving,
finish your
but you
sentence.
don't.
Everybody. Yeah,
You don't.
It's quick.
You don't
It's
see the.
quickly,
You don't.
please.
Hold on. Hold on. You don't see the Earth
I know.
moving. You just see the sun moving, right?
I mean, I'm not in space, so I don't know.
Yeah. So you just see the sun moving from your perspective.
I mean, I guess.
Okay. So is it possible that the sun is moving?
Yeah, for all I know, I've never been to space, so.
Well, there you go. That's what's happening. The sun's moving. The Earth isn't. Pretty simple.
Okay, that's cool. Can I ask my question now?
Sure.
What's 2 + 1?
Wow. That's what you had to get out.
Yeah, please answer it.
Is this a deflection from you
Zero.
realizing
No.
that the sun's moving?
No, please answer it. Like actually.
Just put yourself on mute, dude. If you're this upset, you can't discuss it.
No,
Just put yourself on mute.
actually, please, just please answer it. And I'll put myself on mute after.
Nah, we'll put you on mute if you don't want to put yourself on mute.
Yeah, we'll just put you on
No.
mute. That's fine.
Bro,
That's a
this is like
concession.
so weak.
Answer my question.
That's a nice concession.
Fuck.
Simple. So who was the other guy
Yo, me.
that doesn't understand? Okay, so you
I-
see
I
this. You
don't
see the sun moving, yeah?
Yeah, like I see this. Yeah, for me, it looks like the sun is moving, but
Okay,
the Earth
so
is
why
moving.
you don't believe it's the sun moving? Is that right?
Yeah, it doesn't make sense.
So when you see the sun moving, that doesn't make sense.
Yeah, because like in every
Wow.
book, in every school, you learn that the
Every
Earth is
book.
moving around the sun.
But when you
know?
go outside, you only have evidence for the sun moving.
Yeah, but it's like it's because of how is it called? Like
The sun moving.
it looks like the sun is moving, but the Earth is moving.
Perspective.
You know what I
But
mean?
you know better. You know
Perspective,
better.
yeah, perspective.
So how do you know better that it's actually you moving? How did you figure that out?
Wait again. How do I know that the Earth is moving?
Yeah, when you see the sun moving, you say no, it's not the sun moving, it's me moving. What makes you think that?
Because I'm gay.
Okay, another concession. See how school has just brainwashed you and you have no idea why you believe what you think you believe? That's not something to be proud of.
Let me say something to their age level. Low key, you guys are sus. Don't know what it means.
6, 7.
6, 7.
Yeah, that's a tap. So we can move on. The sun moving always trips them up, isn't that funny? Just blatant reality makes them spiral. Any other globe believers confused about the sun moving? Hmm.
Well, what about found? Or were you talking to found?
No, you weren't.
Okay. Okay, your time to shine.
I guess. I mean, when
Yeah.
I'm in a plane, I can see the curvature. Like people say that the Earth looks flat in the horizon, but I can see the curvature.
You think you see the curvature from a plane?
Yes.
Well, then you're not arguing for the globe model then, because the globe model says it's too big to see it from a plane. So I don't know what globe you're believing in, dude. Some tiny Rick and Morty planet.
No, look. There are people in the chat who said the Earth is like a plate. I don't believe in that.
No one here is saying it's like a plate. We're saying that there's no curvature, so it can't be a ball. There's no curvature, so it can't be a ball. It measures
So
flat.
what is it then? Is it a cube or like what?
Well, flat, I don't know. Flat isn't a shape. Flat's a description of the surface. What shape is a lake?
So you mean it's like maybe like a ball that's been squeeze.
No,
and
it can't be a ball
flat.
because balls by necessity have a
No, you
curved
didn't
surface.
understand me right. It's like you mean it's not totally flat, but it's like a flat object.
Well, the land, the hills and the valleys, they're not flat, but the water's all flat. Yeah.
Wait,
The
so
water
which,
that all the
like,
land's sticking
what
out
kind
of,
of form
that's
is
flat.
the Earth then?
It's a motionless topographical plane.
A what? Can you repeat?
Motionless, yeah, not moving.
Yeah.
Topographical, hills and
What
valleys.
does topographical mean?
Like hills and valleys.
It's rough.
Elevation difference from sea level.
Okay.
Yeah.
Yeah.
Motionless topographical plane. So the general nature of the surface is that there's no curvature to it.
Are you guys actually debating about if the Earth is flat or not?
No,
No.
it's not a debate.
We're just explaining to him what we're saying, which is that there's
So
no
you're
curvature.
sure of that?
Yeah. Of
Like,
course.
How come that you're so sure of that?
Because that's how it's observed, measured, and practically used in reality. The surface, flat, motionless. You can't get much more sure than that. It's like, how are you sure that you're 5'11"? Well, because you measure it. You know your height.
Mm-hmm.
You do the same with the Earth. You measure it.
Yeah, that's right.
Because a ball has to have a curving surface, remember?
So
And they never measured that.
Like, no, like the measurements of the Earth don't make sense. Like,
No, they never
No,
measured
they
it.
make sense. They make sense, but they just measure flat, no curve, no ball. No ball's ever been measured. There's never been
They
any
tell you how
curve
big-
measured.
so all the
They tell you how big it is.
pictures are fake, and all
like
the
Yeah, at school they tell you how big it is, right? The size of it. You can even Google it right now. But they don't. They've never measured it to be that size. They're just giving some numbers there, and you guys are just saying like, "Oh, the Earth is this big," and just believing it.
Yeah, it's just a fantasy story.
They lie to us. Like, every government on the Earth is lying to their people.
No, because most of those governments, they just believe it too.
Round.
It's just a belief, dude. Everyone's believing the same thing.
Okay. So the people don't know. That's what you say.
Yeah, most people are just
Yeah.
like you. They just like heard the story and believed it.
Yeah, but why? Like, where's the other part of these people? Like, some people must know, in your opinion. So why are they trying to hide it?
Maybe they want to control. Maybe they want to control your worldview and how you think and how you believe.
But
maybe
let me just say something very clear. They're not trying to hide it because it's nature outside. You can't hide nature. You can go see a flat level horizon any day. They're not hiding that. You just believe that flat level horizon is actually a globe somehow.
Yeah, but why are they saying then that it's like round?
Because they believe it, just like you. They're doing the same thing you are.
Okay.
Well, they in effect they create this source of truth, quote unquote, in an organization like NASA, and so hold on. Let me finish this thought. Let me finish this thought. No, hold on. I'm going to finish this thought, dude.
Please let me.
No, dude, I'm going to finish this thought. I'm going to finish this thought, dude. Pop yourself on mute for a second,
thing, like the only
or you'll
thing
be
I
put
want to
on
say.
mute.
But
No, dude.
What's happening?
I'm about to explain an important part of this. Right, so they've created an organization which is beyond reproach. They've created an organization in NASA which, if it comes out with any story, you're going to believe it. And you do so because they've told you that you can't experience reality, only we can. We have access to what the Earth actually is, you don't. So if they tell you Uranus is raining diamonds and farting out gas into space, you'll just believe it because you believe anything they say. So the government's managed to create a source of truth.
I just, like, I believe that you don't know anything, so you can't be 100% sure of anything. There's like an equal chance that it's not. Like, I think.
Nah, that's no use. That's no use. You do know some things.
It's like, so.
You're on Discord.
Solipsism is not a good worldview to hold, brother.
Wait,
you can't just say
one
that.
second. You think the Earth is not explored totally?
No, what I told you
That's
is the
not a
Earth's
claim.
surface has no curvature and so cannot be a ball, like they've told you.
Okay.
Yeah, don't
Okay?
try not to
That's
take
it.
the
I don't
solipsis.
like if
Yeah,
you want to
sir.
think it, like it's
Yeah,
fine.
sir. Try not to take the solipsis worldview where you can't know anything, because that's gonna undermine anything you can know. So
Oh,
this
it's not,
that,
and it's not just what I think. That's how the Earth is observed, measured, and practically used. Flat, not curved. So you saying, oh, well, you can think that. Okay, well, if you think otherwise, show us some
I mean,
evidence.
I trust like the scientists and like these people more
You
than
don't know,
some
you're not
guy on
trusting
Discord,
anyone.
but
There's
it's
no,
like
if I asked you who you're trusting, you couldn't tell me a single person. You're not trusting a person, you're just believing an idea. What
Yep.
scientist do you trust?
you don't
Which
know, right?
I mean, you're
which
kind of
scientist
right
proved the
about
globe?
that, but it's like
Yeah,
the
see,
general
you
knowledge of
told yourself that you're appealing to some scientific truth, but in reality, you couldn't even name a single scientist that you think's proven this. You don't
Yeah,
know
it's
who
just
you're
the
appealing to.
idea.
It is just the concept, the idea that you're appealing to. So I would suggest you go and do some research and then come back and follow up on what I told you. The Earth's surface has no
is
curvature.
it even
So it
like
can't be a
does it
ball.
matter if the Earth is flat or
Yes,
not?
reality and the nature of it matter. That's why human beings have spent their entire existence pondering the question. So yes, it matters.
I mean, okay.
Yeah, we make some solid points, man. Just for you to think, just like when you leave here, just think about what we're saying. You don't have to like, oh, the Earth is flat, like tomorrow. Just think about what we're saying. Yeah, a lot of people just believe that the Earth is a globe based on an idea. That's it.
I mean, okay. It's like it's a solid thing. Like, I mean, you can think about it.
You don't. It's not only that you can think about it; you can go outside and experience it, because that's what we're talking about. We're
But it's
talking
like
about
I
what is
see
experienced in reality.
the curvature when I was on a plane. That's why I
No, you
believe
didn't see any curvature.
I did.
If you saw curvature, it would be measurable. So who's measured it?
Yeah, that's true.
What kind of measurable? I see when it's round.
Okay,
Yeah,
so
I
you see
know.
it's round. So give us a measurement of this curvature that supposedly exists.
And somebody
Bro,
should
it's
be
like
able to come back down to the ground and measure it if you saw it up in the air. Somebody can measure it on the ground.
you just say I didn't see it right.
No, dude, he's saying if you
Well, yeah,
saw
because
curvature, then you
it
could
doesn't
come back
exist.
down to the ground and measure it. If it's truly
Yeah.
what you saw.
Bro, it's like a common thing.
Okay, let's say I'm not saying you're lying. I'm saying you're mistaken, right? So the windows on a plane are curved anyway. So maybe you saw it at a particular angle where the window curved the horizon. That's
Why do you see the
possible.
curvature also when people are like skydiving?
You don't.
Dude.
Well, if they're filming through a camera that curves the image, then you might, if they're using a GoPro,
Why does
you
the
could see that
curvature
curve.
not appear
It's
on the
not
camera
curvature
when
of
you
the
film
Earth,
on the ground?
Yeah, that's
because
the
there
problem
is
though.
no curvature.
You're just
There is
saying
no
that people
curvature.
see it.
Perspective.
Yeah, listen, dude. You're just saying that people see it from wherever you are, skydiving, from an airplane window, from a space shuttle. It doesn't matter where you said you see it from. If it's true, that's a globe. You can come back down to the ground and measure it. That should be something you can do if you saw it, right? Or
Yeah,
no?
they're not seeing it, dude. It's just a camera. It's a lens effect.
Yeah, but if you
You
go
have to
down on
ask.
the Earth, it's
You
like
have to ask
you are
yourself
so
that.
small in comparison to the Earth that it appears to be flat.
Nah,
No,
bro,
dude.
you can't do that. Like, if somebody saw curvature and they didn't measure it, that's a problem. They should be able to if it is
Oh,
curving. Yeah.
what you need to do is you need to understand the curvature claim, because at the moment you're just thinking of curvature. You're not actually thinking what the numbers are. So take a 10-mile stretch, for example. That's a simple one. How much curvature do you think exists A to B according to the globe concept?
Wait, a 10-mile stretch.
Over 10 miles. 10-mile stretch, how much curvature in feet? Like a drop from A to B.
Feet, bro, I don't know about feet. That's not the measurement I
Okay,
use.
centimeters,
Centimeters? Oh,
whatever.
fuck, that's like a little measurement. Wait, let me think.
10 miles. 1 centimeter, 10
miles.
centimeters, have a guess.
Like the... Okay.
The drop. The surface is supposed to be dropping down and away from you in all directions because you're on a ball. So over 10 miles, how much has the surface dropped due to curvature?
I mean...
Just have a guess. I don't expect school has taught
I
you.
think you would say none, but I
No,
think.
no, no. I said according to the globe idea,
Oh,
right?
okay.
Because they
According to the
tell
globe.
you what size this ball is, so they tell you how much curvature there's supposed
Okay,
to be.
okay. I would say, bro, that's like so hard to guess. Bro, I can't guess
Just
that.
have a
Can you tell
guess.
me what they think?
I'll tell
Like,
you after you guess.
bro, I don't know. Like,
What
how
is it?
would I
Oh,
know that?
half a centimeter, an inch, 10 centimeters, 20? Just ballpark it.
I
What do you
would
think?
say like little, like really little.
Like a millimeter?
No, not this. Maybe a centimeter.
A centimeter. Right. Okay. Well, actually, they say it's about 66 feet.
What is that in meters?
What, 20, 22 meters, something like that?
Okay. And how do
Okay.
you
So that's
like
a lot more
prove
than
them
1
wrong?
centimeter, isn't it? Well,
How do you prove them wrong?
well, because I ask who's ever measured 22 meters of curvature over 10 miles, and do you know what they say?
Tell me.
Nobody.
No one has.
Wait, but so they just claim that, and it's like not true.
Yeah, nobody's ever checked, dude. Who's checked it? Nobody's
Exactly.
checked it.
But it's also
There's
like
nobody that
the
you
that's
grow
it.
up.
of the Earth isn't.
Hold on,
like,
hold on. Just let
always
me,
like that. You
just
know?
let me, I'm just going to leave you with that. Now, they claim it's like this basically perfect ball. That's what they're showing cartoons of.
It's
So
not
that
a
is what
perfect
they're
ball. The
saying.
surface is like, you know, one
That's
one
what they're
question.
saying.
So
No,
let
hold
me
on.
ask you
That
this.
is what they're saying. That is
If you ask
basically
me a
what they're
question,
saying.
let me ask a reply on that.
No, because
Let
I'm
me
just a way to
reply.
head off. I'm just saying good night, but I'll leave you with that. And you
Bro,
need to focus
you're
on
just
what I
avoiding this
just
right
left.
now.
No. What I
But
said
okay, if
was
you're not avoiding this,
no
at least
one's
tell me
measured the
this one
22
thing
meters,
that will
right?
take only a minute.
Hold on. No one's measured the 22 meters of drop over 10 miles. Do you
Oh,
understand
okay.
that?
If you don't want to tell me that, I will leave. But if like,
Well,
please
I'm
make sure it's
leaving.
true.
I'm gonna go on listen mode, dude. I'm just saying bye, but I'm saying this is what you
Okay.
need to focus on. No one's measured that 22 meters over 10
Because
miles
it doesn't
or
make
any.
sense.
Yes, exactly. The globe
No,
does
no,
not make
it makes no
sense.
sense because the Earth's surface is like
Anyway,
not a perfect, like a perfect
good
ball. That's
chat.
like
Okay, good chat.
really.
You think it's like a lumpy potato, even though they're showing you pictures of a perfect ball in space. Cool story. Okay,
Of
anyway,
course, it's
have a good
like
night, guys.
from this
Enjoy.
perspective,
Miggy
it's
or
smaller.
someone
Yeah.
else pick this
Yeah,
up.
man.
Okay, bye. If you don't want to get
Oh,
into
You
good
this.
gotta
chat.
go,
It was a
man.
good
Like
chat, bro.
everybody has to leave sometime. Like, geez, you can't stay here
I mean,
forever.
I see it's a good point of conversation to leave, I guess.
Well, I mean, obviously, but anyway, yeah, nobody's ever measured that, so
Because
we
it
can
makes no
rest
sense.
assured.
Because like let me like say that it
Yeah,
makes no
go ahead.
sense because there are like the Earth's surface is not as round like as a perfect shaped ball.
How do you know that? How do you know that, bro?
Because I see it.
From where? Where do you see it like that?
I see it from my perspective. I can even see that.
Yeah,
Like you
I
can
know, but
see
what?
that there's like mountains and little like differences in the height of the
Yeah,
ground.
brother. From your perspective, where were you standing where you saw it like that? Like it's not a
Yeah,
perfect
here like
sphere.
on the ground. On the
So
ground,
you
like on the street. I can even see it on the street. Like
are
why
you
would it
kidding me?
make sense to measure a point
Oh, okay.
where a hill
All right.
could be or something like that?
No. Because you're saying that land topography, like a hill, is the curvature of the earth. No. What we're talking about is.
I didn't say that.
All right. So what are you saying?
I'm saying that
What are you saying that you saw the earth?
probably measure it, but you would
Okay.
have to have a like a earth ball that it's perfectly shaped, like
No,
way.
that's not the point, bro. That's not the point. The point we're getting to is that nobody, not even in like the school, that they told you that somebody's actually measured the surface.
Because
Nobody's
it
ever done
doesn't
that.
matter. Like it won't be like it won't even make sense to measure it because of the shape. Like
what? Dude,
So
then why
you're
are they
making it
telling us?
even more
Right,
difficult for yourself.
yeah, then why are they telling us that it's a certain? Jesus,
it makes no
dude.
sense. Will you?
It's hard
What?
enough to measure bumpy Earth, and you're going to say they can measure curvature on top of bumpy Earth?
It has to be like it has to do something with perspective.
What? No, bro. Like you're not. Okay,
That's the
all right, man.
problem.
Oh my god. Listen,
Yeah,
bro,
they
if you're,
hijacked
I mean,
perspective
I
and
let
called
you
it
believe
curve.
that, but it's fine.
no, I mean, obviously, if you think it's perspective,
Like
what's the
I
argument?
don't think it's wrong to doubt things. It's not
No,
wrong.
but it's wrong for you to say things that are not correct too, right? You can't say
I mean,
that
it's
and
my
then just think
belief.
everybody.
It's
Yeah,
the
but your
same as
belief
your
is not.
belief,
Listen,
so
I'll
it's not
tell you
wrong
like
to
this:
say that.
if your belief had any merit, then it would stand, right? but you can't
I mean,
even
if I
say
could
how.
talk to you in my first language, like you would talk to me in English, I would probably be better at explaining it. But it's my perspective, so
I mean, you could say it's your perspective, but it's not. That doesn't measure the surface to have like the curvature that you think exists
but you
on a
can't do that either,
on a lumpy
right?
Earth. It's not. Don't say that I can't do it either. It's not my claim. I'm not saying the Earth's a giant ball, sir. You
But what are
think
you
that it
saying?
is,
You're saying
not
the Earth
me.
is flat, right?
Yeah, and so you think that there's curvature, and I'm saying that cannot be measured because all you notice
But
is
you
the
just
Earth
say you
looking,
can't measure that, and that
brother.
because it's flat.
Yeah. So there's no
And I
curvature
say
measured
I can
except for
see
you.
it, and that's because
Yeah, where do you,
because of
brother?
that I
Where do
think
you
it's
see
not
the
flat.
lumpy Earth? Where do you see lumpy Earth at, bro? Like
So
honestly,
we
like you're
both
not making
make
any sense.
assumptions, and we don't really know it for sure, right?
Yeah. Do you see
I'm
a
not
lumpy
making.
lake?
Yeah, hold on, dude. I'm not making an assumption. You are.
What else?
You're the one making the assumption. I'm not. There's no
Why?
assumption here. Yeah, you're assuming that there's lumpy Earth, and you're seeing lumpy Earth. You're not seeing lumpy Earth, dude. If you see anything that's
What
lumpy,
is
that's
lumpy?
probably a
What does
hill.
lumpy mean?
That means that the Earth is not perfectly a sphere. It's got a
What is
regular, like
sphere?
a regular shape. Like a ball.
Okay.
Hold on. Sorry, I know I said I was going, but just very quickly, I would like to suggest that he's, I think, confusing just general land elevation, confusing this
Yeah.
22 meters drop.
No,
So
I'm not.
what we're
I'm not
saying
being
is,
like,
what we're
I'm really
saying
not,
is,
because
you could
I
do this
know what
over
you
a lake.
mean, but it makes no sense to measure.
You can do this over a lake, right?
Yeah.
So you don't have to worry about the hills and the valleys. Do it over a lake, and that lake is supposed to be level with the earth, right? So it would be following the curve. Yeah. So that water is supposed to be dropping 22 meters. Where's that been measured? Show us a curvy lake. That's the position.
Yeah, over water. Yeah.
But the lakes all measure flat, so people are going out and looking for this 22 meters, but they're finding that it doesn't exist. And there you go, flat earthers, because there's no
Wait,
curve.
let me one second. I have to research something.
Someone show him some examples. Just show him some laser tests, explain it to him. He sounds like he could understand it.
Yeah.
And don't worry about the language. Your English is pretty decent. And if you don't understand something, just ask us to explain it or simplify the language. We're happy to do that. But anyway,
Okay,
have a good night, guys.
I want to see it, man. I want them to give the old college try because it's always good for them to actually put their best efforts if they're thinking that they have an answer. Because if we shut them down and just give them what flat Earth is, then they're going to be left with I can prove it, but all this other stuff. So they gotta do their best, or at least attempt to. Anyway, I mean, But currently, I think he's just going to go look for something. I'm going to actually be leaving here.
I'm just
another
searching
5
for
minutes.
because of my language, you know.
He's like, it's not a perfect sphere.
I mean, okay. It's hard to it's probably not measured when you see it on the river. You mean the river, right?
No, I mean any large body of water. There's
So
no
also
convexity
the
over that
ocean,
large
you
body.
mean?
Yeah, any large body, sir. Any
So
large
if
body.
you're on the ocean with a boat, and then there's another boat in front of you, but way farther, you can only see the upper part of the boat because of the curvature. Why is
That's
that?
incorrect. That's incorrect. You just
No, it's
your
not.
statement is yeah, it is. Have you ever made this observation yourself?
Yes.
Okay, how many times have you made this observation?
I think 3 times, because I was on 3 times I was on a cruise, and I see that.
You saw the ship disappear from the bottom up?
Yeah. No, I was looking with what is it called? These glasses, you know?
Okay. What distance away from you were to the ship?
A large distance.
How far away were you?
I mean, how
like
could I
mind you,
measure?
mind you.
No, I don't know.
Mind you, it's important. Well, it's important because if you're seeing the ship move away from you and it's going a distance away, we're going to want to know what the distance is to that ship because if it's farther than the predicted amount of Earth curvature,
many kilometers.
what? Many kilometers is not an actual numeric value, sir. And it's important. Like it's specifically
It has to
important.
be
Like
an
I said,
American measurement or what?
no, just like a distance away. You could
I would
meters or
say like 50 kilometers or something or more,
50 kilometers.
or even more. I think I don't have a good like. I
Yeah,
can't
I mean,
guess
yeah, yeah.
you know, I don't really know the distance from an ocean
Well,
perspective.
the hard. Okay, so the
It's kind
hard
of
thing
hard to
about
guess
what you're
that.
saying, well, the hard thing that you're saying right now is that nobody can actually put to the test
But
the
like
distance away.
one thing, like why could I see the ship from
Bro,
up,
you're not
but not
listening to
down?
me. You're jumping on what I'm saying. You're not listening. Just hear what I'm saying, okay?
Okay, I will hear.
The important thing about the distance is if you tell us that it's really close or far away, like specifically what distance, then we can know if it's like what you're saying could be validated. That you're saying, hey, I'm making a case for the Earth being a globe, so that the distance away is going to be this specific distance, and then the curvature should be appearing because I'm really far away. So that's the curve. So then we could talk about it. But if you don't give us any information, we don't know if you're like, like a mile away. Like we couldn't tell. But if you're saying it's really far away and you don't give us a numeric value like distance, that makes it difficult
An
for us to
American
even
value.
know numerical, like numbers. You can't just say something like it's far away or it's close. That's not something specific. But if you say it's 10 meters away or it's 1,000 meters away, like that's something specific. You're giving a number value to how far away it is.
Well, I think it's like maybe even like 20 kilometers or something.
Okay. Well, at least that's something to work with. I mean, it sounds like you really don't know, but then it's going to be difficult because if we're saying there's a specific amount of Earth curvature that should be present, and then we got to find out how
But
high off
isn't
the
this
ground.
like a common thing? It doesn't like does this not like contradict your statement that like the Earth on an ocean or in a river like that you can see the curvature like when you see only the upper part of the ship?
No,
Why not?
because it's an optical phenomenon that occurs that can cause that, and also it could be the angle that.
What causes
Bro,
that?
you're not
Like, what
allowing
causes
me
it?
to finish, bro.
Like,
You have to stop talking when I'm talking, brother.
Oh, let me
You have to at least let me.
make this
Dude,
further.
okay,
What
you
causes
go
this
ahead. Finish what
besides
you're saying because
Earth curvature?
obviously I can't finish what I'm saying.
Okay, tell me now.
No, you finish what because I don't want you to interrupt me. Go.
Okay,
Tell me what you're gonna say.
Okay, then I will finish it. What does that cause besides the Earth curvature? Like, you must know. If you say it's not that.
What does that cause? What do you mean?
Yeah, what does
It's
the
hard.
optical illusion
You're. Can anybody understand what he's trying to ask? What does that cause? What causes it? Is that what you're saying?
The optical illusion is caused by besides the Earth curvature, and you're saying it's not the Earth curvature.
Yeah, there's optical phenomena like mirages that occur over distance. So there's a lot of effects that occur, and including the distance you are from the ground. So what
But can you
angle you're viewing?
exactly explain them?
Brother, I am in the middle of telling you. Why do you keep interrupting me? Stop doing that.
You paused.
I paused so that I can it's called taking a breath, bro. Can I do that?
Yeah, you can do that.
All right.
I just asked a quick question.
Oh my God. Just keep going, dude. Somebody else take it. I can't deal with this guy.
I tried.
You may never. Yeah, no, I tried.
Hey, buddy.
Buddy,
you have to control the diarrhea of the mouth, bro. You can't just be doing that to people. Come on.
Are you talking to me?
Yes, talking to you. Because there's other people listening. There's other people listening. There's other people listening, and you are interrupting other people. So that's not how communication works. You have to wait for someone. No, you have to wait for someone to finish what they're saying. Then you reply. You don't do it in the middle of their sentences.
Fine.
That's how communication works. You know this, right?
No, you interrupted me.
The guy interrupting say he's being interrupted, huh?
It's fine. Like I don't.
No, it's not fine.
Bad, but he can speak now if he wants. I think
no, he doesn't want to talk to you. He doesn't want to talk to you because he knows now that he's gonna be interrupted.
He won't.
When someone is in the middle of their sentence, that's not a
I
cue for you
know
to
that.
start speaking. No, you don't know that.
Okay, then well, you don't talk to me, right?
No.
That's fine.
No, if you just gonna behave like that, we don't want to talk to you. Whenever you learn and you know that you cannot be speaking in the middle of someone else's sentences, then we might be able to speak to you. But before that, once you learn that, then you might
don't
be
need
able to have a
Tell me
conversation.
that. I already know that.
But he told you like 5 times and you still don't get it. I don't
But he
believe you
interrupted
get
me
it yet.
too.
I don't believe you get it. I don't believe it
Okay,
until
then.
you demonstrate it.
Okay. Okay. I mean, it's quiet now. You can talk if you want.
Okay, so you believe that's the only reason that a boat is going away from your view, it has to be because of the curvature of the Earth. There's no other reason.
Can I talk now?
You just did. Can I talk now?
Wait, you are asking me a question, right? Shouldn't I answer?
I mean, if you want to, you don't have to.
Yeah. I mean, it seems to be the most reasonable solution.
How many of the other reasonable, less you said that's the most reasonable, what are the other ones that you discarded and checked out and said this one is not reasonable, this one is less reasonable, this one is less than the other one, and this one is the final lesser of all of them, and then you came to the most reasonable, the curvature? How many did you checked, how many variables did you check and discarded before coming to the conclusion that it has to be the curvature of the Earth?
So, it's like it's reasonable because I can compare it to different scenarios. When I would be on a mountain,
How many variables did you check? Tell me the other variables.
Bro, you are like criticizing me.
The variables. Give me a list
I'm
of
not
how many
speaking to
you
you if
checked.
you interrupting me after you're like making a big thing out of this.
So are you gonna answer my question or no?
Nah, I'm not talking to you now.
Okay, so you're not gonna answer
I mean,
my question.
if you would learn to not interrupt people, maybe then.
Are you gonna have a follow up? Are you gonna answer a question or no?
Yeah, it's like you guys are having two separate conversations. The audience is getting a little frustrated. Not your fault, Jamesy.
It might be a language barrier.
Nah, I don't even think so. Bro, okay. If you're on the mountain and you are on the peak of the mountain and you go down a little bit and the other person is going like down also a little bit, but on the other side, then you would only see the upper part of the person, right? And it's the same with the ocean. When you see the upper part of the ship, That's why I think that this is the solution. And I don't really compare much with it because it's a thing that makes sense.
Yoder, you wanna reply?
I mean, I'm not sure what you're getting at here. Are you saying that the two people walk away from each other and the mountain stays where it is and the people just see the mountain getting smaller relative to how far they are from the
No, you
mountain?
didn't get me
I'm
right.
really trying to struggle to figure out what you're saying.
No, I'm saying that there's two people on a peak of a mountain, and then they go in different directions and go down the mountain until
Yeah.
they only see the upper part of the other person because of the curvature. And it's the same with the water when you see another
Oh.
ship in the distance.
Yeah, I've never seen that.
Okay, then you never be like on the ocean and see that.
No, I used to live in Hawaii
it
across
is
the
like
street
that.
from the beach. I used to watch ships sail out of Pearl Harbor every day.
Okay,
And
maybe you didn't see them like far enough. But
I mean, I saw them very far away.
okay, then we have different experiences. It's fine.
Yeah, and I've never seen anybody show me ships going over the curvature of the Earth in any video or picture or anything otherwise.
Okay, then look it up, search it. You will
I
find
have.
enough pictures of
I
it.
have, and I know what I'm seeing, and I know in all cases, it absolutely is not presenting me globe curvature.
Why not?
Well, first off, people don't present anything that seems to be causing globe curvature where the globe should be curving. What
Why
people do
shouldn't the globe
present
curve?
are things like waves and shoaling and miraging effects of boats as they're getting squished and stretched in the distance. I've never seen globe curvature.
I feel like this is more a thing of you don't want to believe it.
No, I've been searching for globe curvature for about 5 years now. Can't find it.
So what did you find?
That nobody is able to demonstrate globe curvature, and
But I just
all
did.
evidence is on the contrary. Everything looks flat. It's crazy, but it's true.
Yeah, it's because of perspective.
Yeah, it's not curvature, there's perspective.
Yeah, it appears flat because it's like such a big thing.
So your evidence for the globe is how flat it looks?
Nah. My evidence of the globe is what I said earlier, that I can see the curvature if I'm high enough, and I can also see satellite pictures, which I believe are true. I mean, I don't blame you if you don't believe they are true. And I can see things from upper perspective when I'm in the ocean, like ships.
I've seen satellite images of a flat horizon. I've seen images from CloudSat. CloudSat is or was a constellation of weather satellites. They have sideways looking cameras, not looking straight down at Earth only, but also looking out the side at the horizon. And they show a flat horizon,
Like, who published
1,120
them?
kilometers, flat Earth. It's beautiful.
Like, who
And it's in
published them?
infrared.
Who published them? Like, who?
Organization in the United States called NOAA, NOAA, the
And
National
these people
Oceanographic
believe that the Earth is flat.
Aeronautic Administration.
Oh, they are government, like government stuff.
Yeah, and it's a joint program between NASA and NOAA.
So they like posted something where you see the Earth is flat.
Oh yeah, absolutely. I mean, that guy you were talking to earlier, his name's Gemsy. He's got a ton of information about this. It's really great.
Did he also like bring you into this?
Into flat Earth, no.
But you okay?
I found out it was flat myself.
I see.
Yeah, I mean, anytime you think you have evidence for a globe, it becomes obvious really quickly that it's not.
I mean, I wouldn't say that. I would say it's pretty obvious that it is, but
well, can
I
you find
think we
a
just have
particular
different.
case?
We want to have different beliefs. It seems like more
No,
than
I mean, it's true.
what makes it true? Like, you don't even have a proof. I mean, I don't have much proof either, but I would say I have much better proof than you.
I don't think so. We got a server with terabytes of evidence.
Yeah, but we have like way
Discord.gg/flat Earth.
more evidence against it, probably.
Well, that's a funny thing. What you think is evidence against is actually evidence for. Most of our evidence for flat Earth seems to come from official sources.
Okay. I think it's
Right.
like it's a perspective thing, but it's fine. I'm just like, I will stay here and listen to you a little bit more.
Yeah, that's fine. I mean, we're not going anywhere. We're here 24/7.
Yeah, I
We've
believe
got
that.
people all over the world, and
We've got the best laser tests on Earth.
Cool.
One of the best places to do a test for curvature is over water, over frozen water, or over a salt lake or a salt bed that has been recently rained upon, so it produces a mirror, a flush mirror image of the sky. Not once has curvature ever been measured over such things. We got flat earthers that take infrared cameras on airplanes and zoom in on the horizon. No globe there. What does the globe side present? Well, they present surveys of the Earth. They present surveys where they survey the Earth flat, and then they pick a globe model, and then they contort their flat Earth measurements to fit the model, and they call that a globe measurement. This happens all the time. There's a whole field dedicated to this called geodesy, Geodesy. Geodesy. It's when you measure Earth flat, and then you mangle your measurements with calculations on a fake globe model ball. It's the most insane thing. Not a single surveyor in this entire field of geodesy is able to measure the Earth directly as a sphere. They have to mathematically contort it to fit a globe model. And they've got hundreds and hundreds of different models of the globe. And they're not all the same, which means they aren't fully compatible with each other, which means nobody has a true map or a true concept of what the globe is or what it even ought to be. Within about a year or so of looking into this, I decided that I needed to look at what the surveyors are doing, the people who claim to actually measure the Earth for a living. And it was quite a frustrating endeavor. Nobody's actually measured curvature in accordance with the radius of the globe. They take models of the globe and they bend their measurements to it. It's almost like taking a texture map in a 3D program and wrapping it around a ball. And this is what they do over and over again, and everybody's fine with it. And everybody pretends that they're measuring the globe, and they're not. It's crazy. Like, what the hell is wrong with everybody? It's funny because they don't exactly tell it like that, but that's exactly what they do. It's the process they describe. They think that the globe model that they select in order to contort their measurements onto, that globe model itself has arisen iteratively after many, many measurements over many years, this, that, and the other. It's just not true. Ultimately, their globe models come from measuring angles to stars in the sky at night. That's right. That's how they created the globe. If they could demonstrate that they were measuring the globe itself, then they wouldn't need what's called a reference ellipsoid to make it work. So this invites a lot of questions like, well, does that mean that they're purposefully mangling the true distances and even the orientation of things? The answer is yes. Yes, they are actually. I mean, does this mean that our flat Earth laser tests are debunking globe Earth distances between continents? Why, yes, absolutely. You see, when you use latitude and longitude on a globe, you're calculating distances on a map. You're not measuring distances when you look at two places. Like if you say New York is at this latitude and longitude, and Los Angeles is at that latitude and longitude, you can calculate the distance between the two, but that doesn't mean it lines up in reality that way. When they claim that there is a relationship where 1 degree of angular displacement of a star in the sky on a great circle route happens when you travel 69 miles or 60 nautical miles over the surface of the Earth, that has never been measured. That's a calculation. Sure, they can measure the angle. Fine, I'm not disputing that they can measure angles. But it's the angle distance relationship that has never been substantiated via measurement. Has anybody proven that? I've never seen anything but an extrapolation within an unspecified margin of error to substantiate the 69-to-1 rule. I've only seen extrapolations. I've seen people measure arc seconds or arc minutes of degree in the sky and then extrapolate that out to a full degree. But nope, never an actual measurement. So this means, I mean, does that relationship hold everywhere on the globe? And the answer is no. Like even with globe Earth geometry and mathematics and surveying, astrogeodetic surveying, the 69-to-1 rule is a rule of thumb. It doesn't even hold true in the globe paradigm everywhere consistently around the world. Why is that? Well, they've got a lumpy geoid. They pretend that Earth has this potato shape of a gravity field, and this screws up everybody's ability to get plumb measurements that are parallel to each other, or radial out from a common center, I should say. And this will have an effect on your distance calculations. That's one issue. You know, and they figure this out when they try to establish the 69-to-1 rule, and they go to look at a star to see where it should be, and it's not. They're like, oh crap, okay, it must be Earth's gravity field bending the starlight. That's what the geoid does. So they make all these ad hoc patch corrections here and there, salvage some kind of semblance of a working model. But yeah, I mean, I don't accept a 69-to-1 relationship at all. I mean, beyond just a map distance, calculated map distance. That's all that is. You know, measuring angles to stars is another challenge because within all the manuals, they tell you for practical purposes, you don't want to take angles above like 60 degrees of elevation. If you're looking straight overhead, you're going to have a problem. And you don't want to use the very narrow low angles to the horizon due to what they claim is astronomical refraction or terrestrial refraction even. And so you got to use the meaty middle of your field of view, somewhere down below from directly overhead and somewhere above from directly in front of you. That's where the stars are that you want to take elevation angles to. But the assumption is that every star you're taking an elevation angle to has a GP that corresponds, and you can work that out with the geometry. And yeah, you probably can work it out geometrically, conceptually. But if you're not really taking 90-degree zenith angles to these stars, because it's impractical for many reasons. And, you know, what are the chances of you being directly underneath a star perfectly 90 degrees? And then for how long does that last? These things are always moving in the sky. I mean, is it possible that you could even claim that or counterclaim that nobody's been able to establish a 90-degree zenith angle to any star at any time in human history. It's just assume that that's the case, especially Polaris. I mean, has anybody stood underneath Polaris? I mean, what, from a dinghy in the Arctic waters? Yeah, good luck doing that. But I mean, this is what our maps are all based off of: latitude and longitude. This is how the globe was constructed. Just got one belief after another and a lot of geometry and ad hoc explanations. Meanwhile, flat earthers take lasers out and infrared optics out, and we observe and measure Earth flat every time. Crazy world. Suppose that you thought you lived on a globe, right? Let's say you're looking northward. You see Polaris, right, in the Big Dipper, and that's beautiful right in front of you. Suppose, I don't know, then you're at a particular location, 45 degrees north latitude. All right, so you're looking directly north. You're at 45 degrees north latitude. So Polaris is assumed to be about, 45 degrees up in elevation in the sky. Let's say from there you look directly west. You turn 90 degrees west. And then you look straight up to get an elevation to a star. That star is in the south. I hate to tell you, Globers. Think you got this figured out? Yeah, it's pretty funny, I think, because you're facing 90 degrees west. But you got to remember, at 45 degrees north latitude, that's a circle. So really, when you go to look due west, that line of latitude is curving to the right off into the distance and bending down. So if you take an elevation while looking 90 degrees to the west, and you look 45 degrees north and grab a star there, that thing is way over the south somewhere. And it's also not going to be moving at 15 degrees per hour in your field of view. So how do you know where you are? How do you know that you're going to be following a great circle route, especially when all these stars are moving? How do you actually stay on your 45-degree north latitude and travel along that? How do you use stars to do that? Because that's not a great circle route. Does anybody really have an appreciation for how difficult this is?